Hey there, Science2 kiddos. I'm going to use this final set of slides and video to go through what's called the combined gas law. So we've covered the three gas laws separately: Boyle's law, Charles's law, and Gay-Lussac's law. And it turns out, as many of you hopefully have maybe put together, is that these can all be combined. So let me show you. Let's take Boyle's law first. If I were to write it out, P1 V1 is equal to P2 V2. Now let's use a different color and bring in Charles's law. Can we squeeze Charles's law in here? Well, I know I've got the P1 up here, and then I've just got to divide by T1 down there. Here's the P2 and divide by T2. And so I've got Charles's law in there now. And now let's see if we can bring in Gay-Lussac's law. Here's V1 over T1 and V2 over T2. So there you have it. You have all three of the gas laws combined into one. To make that a little neater, here's what it looks like. It's called the combined gas law. Temperature, as we have discussed, is always in Kelvin. This is going to be the number one mistake that a lot of students make. You have to convert, if we ever give you Celsius, you have to take the degrees Celsius and add 273 to it to get the actual Kelvin number. Pressure can be in any unit as long as they match, right? So if P1 is in atmospheres, then as long as P2 is also in atmospheres, you're good to go. Or millimeters mercury or kilopascals and so on. Same thing with volume, right? Volume could be milliliters or liters as long as they match. If V1 is in milliliters, then V2 needs to be in milliliters. If V1's in liters, then V2 needs to be in liters. So this just means there's a little bit more cross multiplication that needs to be done. So let's go ahead and also just more units that need to be identified. And so make sure you're reading these problems carefully to figure out what your initial and final pressures, volumes, and temperatures are. So let's take a look at this practice problem. If I initially have a gas at a pressure of 12 atmospheres, there's my P1, a volume of 23 liters, there's my V1, and a temperature of 200 Kelvin, so that's convenient, already given to us in Kelvin, that's going to be T1. And then I raise the pressure to 14 atmospheres, that's P2, and increase the temperature to 300 K, that's T2. What is the new volume of the gas? So we don't know V2. That's what we're trying to find. That's what's unknown. So then you just got to plug into the equation. I'm going to do my best to have save room here. So following off this framework right here, then I'm going to take my first pressure, which was 12 atmospheres, multiply that by the first volume, which was 23 liters, divided by the first temperature, which was 200 Kelvin. And I know that is going to be equal to our second pressure, which is 14 atmospheres. And again, those units match, so we're good to go there. Our second volume is what we don't know. And our second temperature was 300 Kelvin. So all you need to do to solve this is to cross multiply. So what I'm going to do is basically take 12 times 23 times 300. Actually, you know what? Let's use a different color for this. Might make it a little clearer. You're going to take 12 times 23 times 300 Kelvin, right? Those three. And I know with those three multiplied together, it should be equal to these three multiplied together. 200 times 14 times V2. So let's rewrite that out as one long equation. So 12 atmospheres times 23 liters times 300 Kelvin. So again, this is just cross multiplication that I'm doing here, right? Just cross multiplying these sides and these sides. Okay, so I know that's going to be equal to, let's get the cross multiplying thing out of the way so we can still see it. It's going to be equal to 14 atmospheres times my unknown V2 times 200 Kelvin. Okay, and so again, now to solve for V2, we just need to divide away all these other factors, right? So this is what we're going for. right here. We want that by itself on that side. And so you just need to divide both sides by first 14 atmospheres. Let's get that out of the way. That brings the atmospheres over. And then divide both sides by 200 Kelvin. So as you can see over here, now 14 atmospheres will cancel each other out. 200 Kelvin cancel each other out. So those are now all gone. And we're left with just V2 being equal to this whole mess here. So then you just got to mathematically do that. 12 times 23 times 300 divided by 14 divided by 200 Kelvin. Or you could solve the top and bottom and solve it however you want to do that. But either way, you should get an answer of 29.6 liters. And you're welcome to check me on that. Here's a neater version of that. If you have trouble reading my handwriting, this is it with it all typed out. Again, this is just me showing you the initial equation. And then the final answer, I didn't actually type out the cross multiplication step. All right, you'll have a chance to tackle this one on your own with the Edpuzzle. Again, just follow the same framework I did before. Identify your variables. Please note that temperature is in degrees Celsius in this one, so you're going to need to convert to Kelvin. Remember just to add 273. So give it a go. All right, if you gave this a try, let's take a look here. So I'll just walk through the variables really quickly. So that should be our V1, 28 liters, 45 degrees Celsius, that's our T1. And if we add 273 to that, we should get 318 Kelvin. That's what that is. Unknown pressure. So unknown pressure, so we don't know P1. So that's a little unusual for this one, but has a volume increased to 34 liters. So there's our V2. 35 degrees Celsius, there's our T2. And again, if we add 273 to it, we should get 308 Kelvin. And here's our P2. And so I just plugged into those equations there. And all you need to do is cross multiply these. So we know P1 times 28 times 308 is equal to 318 times 2 times 34. And then you're just dividing basically that side, the 318 times 2.0 times 34 divided by 28 divided by 308. That'll give you P1 by itself. You should have gotten 2.51. We'll get more practice with this. This is as hard as the math will get in this. But again, what's more important is just kind of going back to those initial gas laws and just really cementing in your mind these relationships, right? That pressure and volume of a gas are inversely proportional, whereas everything else in terms of temperature is directly proportional, right? Pressure is directly proportional to temperature, and volume is directly proportional to temperature. Hope this was helpful. Thanks.